this video, we're going to look at simplifying radical expressions and also the connection between radicals and absolute value. So if you notice that if I take, for example, here, if I take and square -3, I would get a +9, and then if I go ahead and take the square root of that, I get 3. What went in was not 3, right? It was -3. So what came out is not the same as what went in. It's actually the absolute value of -3, which is 3. And that will happen if what goes in is a negative number. So you'll notice, and it has to be an even root. Okay, so if you notice here, if I take -3 and cube it, I would get -27. And then if I take the cube root of that, it is -3. And so we don't have that same issue where it's actually the sign was changed. That's just the same as what went in. And the reason is because we have an odd power and an odd root. Okay, it's only when you have an even that will, multiplying itself by, twice with that squaring, it gives you negative times negative, which would be a +9. So what comes out is, square root of a positive, which is +3, and we have to change the sign of what was originally in there. Okay, so you'll notice that actually the definition of absolute value is you take a number and square it, and then take the square root of that, and what comes out is guaranteed to be positive, and that is how we can actually define absolute value. So we have to worry about that, not actually all that often in this class, because usually the instructions are going to say, assume the variables are positive, and then we don't have to worry about it at all because what went in is going to be positive if it's an x. Okay, but let's just do, like, for example here, because it didn't say assume it's positive, then we have to say, well, what went in isn't necessarily the same as what comes out. It's just going to make sure that it's positive. Okay, so let's try this one. If, let's see, 2 times 2 is 4, times 2 times 2, that's another 4, that'd be 16. So 2 to the 4th is 16. So the 4th root of 16 is 2, and then because it didn't tell me that x is necessarily positive or negative, I don't know if when I take the 4th root of it, it's going to be x, or if x was negative, it's going to be a positive, right? So it would be the absolute value of x. Okay, so same thing here, square root of 9, that is 3. Square root of x squared is absolute value of x. Let's see, square root of y to the 4th, that is y squared. Now y squared is, if I square something, that's guaranteed to be positive, so I don't have to take the absolute value of it. I mean, it wouldn't be wrong, it's just already positive, so it would be duplicating our work. We don't have to make it positive if it's already guaranteed to be positive. So anything when we square it is always positive. Okay, and then the square root of z to the 6th, that's z cubed. And we just found out in this one that if you cube a number, -3 times itself 3 times, that's -27. All right, so z cubed, because it has the potential to be negative, but I know that it's not because I took some number and took it to the 6th power, z to the 6th is positive, and then when I take the square root of a positive, it's going to be positive. Okay, so that's when I need to use absolute value. Okay, and then this can get simplified just a little bit. We can combine everything that's in that absolute value. So it would be 3y squared times the absolute value of xz cubed. All right, so it's kind of technical and tricky, these ones, but for the most part, you're going to just notice it almost always says assume the variables are non-negative or, positive, and so we don't have to worry about all that absolute value. All right, let's do some more. And we'll notice we don't have to worry about absolute value. Okay, so on here I've got square root, so I'm going to rewrite 32 as 16 times 2 because I can take the square root of 16. And x I'm not going to be able to take the square root of, that's simplified as much. Now y cubed, if I rewrite that as y squared times y, then I can take the square root of, let's see, 16 and y squared. So that would become 4y times square root of 2xy. Now if it hadn't said my variable was positive, I would have had to use absolute value. But I don't need to this time. Let's erase those. Okay, now the second part, I have y times 8. I'm going to think of that as 4 times 2. And then I can take the square root of 4. So this would become y times square root of 4 is 2. And then we can't simplify square root of 2xy any further. So this gives us that we've got 4y times square root of 2xy plus 2y square root of 2xy, and then we add those together to get 6y square root of 2xy. And we're done. Okay, let's try the next one. Be really on the lookout and alert for what type of root we are in. So I need to think about fourth. Let's see, it's even, so it's probably 2, let's see, 2 to the fourth. That would be 4 times 4, that's 16. So I'm going to do this as the fourth root of 16 times 2, x to the 12th, y to the 8th, z to the 4th. All right, now I can take the square root of 6, or the fourth root. Oop, be careful. Fourth root of 16 is 2. And then the fourth root of y, or x cubed, is x to the third, and that's because the power is the numerator of that fraction, the type of root is the denominator. So with our numbers, we take the actual fourth root, but with our exponents, we divide by 4. So we'd get x cubed. And then I can take the fourth root of y to the 8th, and that is going to be, just divide that 8 by 4, and so we would get y squared. And finally, we can take the fourth root of z to the 4th, and just divide by 4 there, and we would get z. And we, oh, don't forget, we've got a 2 that still didn't get simplified, so we need to multiply that times the fourth root of 2. All right, let's do one more. Here we're multiplying, so I'm going to take, let's see, if I write this as exponents, it's a little bit easier. So I've got 2x to the 1/2 times 3x to the 1/4. Okay, and then I can multiply my numbers, so I'd get 6x to the 1/2, and then x to the 1/4. We get to add those exponents. 1/2 plus 1/4, right? Okay, right, because if you had x squared times x cubed, for example, that would be x to the 5th. You just add exponents when you've got x times a power times x times a power. Okay, so we're going to add exponents, and we will get a grand total of 6x to the 3/4. And if we're, just see what the directions say, if the problem is given as a radical, often we're being asked to write the answer as a radical. So because there's a 4 in the denominator, that's a type of root, so it's the fourth root of x. And then that 3 in the numerator is telling us the type of power. And this is, so it would be x cubed. Add x, the root. All right, let's try one where we have binomial radicals. So we're going to multiply our square root of y times everything. And so then it's also being multiplied by the square root, oops, trying to talk and write at the same time, it's always dangerous. Okay, and now we're going to do the same thing with that square root of 2. Multiply that times the square root of y and also times the square root of 2. So square root of y times square root of y is just square root of y squared, that's just y. And now I've got a negative square root of y times square root of 2, that would be minus square root of 2y. But then I'm adding the square root of 2 times square root of y, that would be the square root of 2y. So those are just going to add up to 0. And then here I've got square root of 2 times square root of 2, that would be square root of 4, which is 2. So my final answer ends up being y minus 2. Now that's kind of a special case where you'll notice that everything is exactly the same in these binomials except for the sign, and that has a special word, that's the conjugate. Those are conjugates of each other. And when we go to divide radicals, we're going to use that idea of conjugates in the future. So when you're dividing radicals, the big rule is we're not supposed to have any fractions under a radical sign, and then we're also supposed to not have any radicals in the denominator. So here we can take the square root of the numerator times and separate those, divided by square root of the denominator. So this would be 1 over square root of 7, but the rules say no radical in the denominator. Okay, so what I need to do is just whatever it takes to not have a square root down there. So if I can multiply by, I can't change what I was given. All I was given was just, this original fraction. But if I just multiply by 1, it doesn't change the value. And I'm just going to use a super well chosen 1 because anything divided by itself is just 1. So if I multiply by square root of 7 over square root of 7, it doesn't change the value of what was given. But what happens is then I would have 1 times square root of 7 in the numerator, which is square root of 7, and then in the denominator it's square root of 7 times square root of 7, square root of 49. That is not a rational it doesn't have a radical. It is a rational number, so I've rationalized the denominator. Mission accomplished. Okay, let's look at this one. So our mission is just do whatever it takes to not have a radical down there. Now this is a cube root. What I wish is if I had a cube root of something I could easily take the cube root of, which would be like 8x cubed, but that's not what I have. Okay, instead what I have is this cube root of 2. So I'm just going to give myself what I need. And so to do that, if I multiply by the cube root of 4x in both the numerator and the denominator, that's going to give me what I need. Okay, so now, what do we have? Square root of 4 is 2, and that's being multiplied by the cube root of 4x. And then in the denominator, we have the cube root of 8x cubed. Isn't that lovely? And I can take the cube root of that denominator, let's see, and that would be 2x. Okay, and now I just need to do the final step and just simplify those 2's. Will divide out to 1, so that just gives me the cube root of 4x all over x. And then I'm done. So the mission has been accomplished. I don't have a radical down in the denominator. All right, so sometimes in calculus we're going to be asked to rationalize the numerator, and so let me just show you how you would do that. Here I notice that there's radicals. Okay, so what I want to do is use the conjugate. So I'm going to do exactly the same. Everything's the same except that I'm going to have a different sign in the numerator. or sorry, sign, one's negative, one's positive. Okay, so I need to do the same thing for both the numerator and the denominator because I can't change the value of what was originally given. So in the denominator, I'll have h times square root of 2 plus square root of h plus 2. Okay, now we're going to start multiplying and FOILing this out. Square root of 2 times square root of 2 is the square root of 4, which is 2. And then we have plus square root of 2 times square root of h plus 2. And, oops. Okay, and then we would have minus that same thing, square root of h plus 2 times square root of 2. And those are just going to add up to 0. And then finally we have negative times positive would be minus square root of h plus 2 times square root of h plus 2 would be that whole quantity squared. So let's see, we would end up getting 2 minus square root of the squaring the square root, that just undoes it, and so we would have minus the whole h plus 2. Just distribute your negative. Let's see what we have down in the denominator. Still h times square root of 2 plus square root of h plus 2. Okay, let's see. So we get 2 minus h minus 2 all over that same denominator. My 2's just add up to 0, and so what we end up with is negative h all over h times square root of 2 plus square root of h plus 2. Anything divided by itself is just 1. Little precursor of calculus here. Some of this algebra gets really long. Okay, and h plus 2. So it seems like just kind of this flourishing of algebra, like why in the world would we ever do this? But it will actually help us solve problems in calculus and do all kinds of amazing things like finding the slope at one point, the instantaneous slope, because what we're going to be asked to do is figuring out as h approaches the value of 0, what is this thing worth? And our original, oh, that was a minus to start with, h plus 2, our original had zeros in both the top, and so it would be hard to evaluate because we had h down in the denominator, so it would be undefined. But by using algebra and rewriting this, we can see actually as h goes towards 0, here, there's everything else is numbers, so that would actually end up being, it would get closer to negative 1 over square root of 2 plus square root of 2, which is an actual number. So anyway, that's kind of where you're going to be headed in calculus, and so sometimes when you're being asked to do that really specific thing of rationalizing the numerator, that's what's going on.